Hello. Today I'm going to give you notes on how to find the distance between a point and a line. So first we have to talk about the distance. Distance between a point and a line is always going to be at a right angle. So this, I'm not making it perfect, but a right angle is the shortest possible distance. Just imagine that you're here walking in the hot sand at the beach and you want to get your feet into the water. If you needed to get there as quickly as you could, you would go directly towards it. You wouldn't walk this way to get to the water. That would not be the shortest distance. So distance is always talking about the shortest distance. So that means what we're going to need is a perpendicular line. So since we need a perpendicular line, and we're going to come from P, then we're going to need a perpendicular line including point P. Point P is located at 5, 3. So we're going to find the slope of line M, and we're going to find a perpendicular slope through P. So first, the slope of M, if we start here and go here, let's say, that's going to be going up 2 and right 3. So my slope of this line is 2 over 3. My slope is 2/3. So this line that we're going to make is going to be perpendicular to that. So it's going to have a slope that's the opposite reciprocal. So 2/3 is positive. So this one's going to be the opposite, negative. And if I give the reciprocal of 2/3, it becomes 3 over 2. So the slope of this line is going to be negative 3 over 2. So now I'm going to begin at P and use that slope to draw a line. So I have to go down 3 and over 2, but wait, I can't really go that way, so let's go up 3 and back 2. Sorry about that. That point right there is where I connect to make a perpendicular line, which is where we kind of thought already. So if I connect those two, now I have a perpendicular line. Let's just double check. 1, 2, 3, down 3, 1, 2. So now we need the equation. Actually, we don't need the equation. We already know this point. This point is located at 3, 6. So we just need to find the distance between 3, 6 and 5, 3, and we've got it. So our intersection point we said was 3, 6, and so now we're going to use the distance formula. So remember, the distance formula is when we take our x's and subtract them and square that difference. To that we add the difference between our y's squared. All right, so we're going to plug in the numbers here for those 2 points. And remember, we're using 3, 6 and 5, 3. I'm going to write that here so that we can remember what we're doing. 3, 6 and 5, 3. All right, so my x's, 5 and 3. 5 minus 3 squared. And now my y's, 6 and 3. So I'm going to go 3 minus 6. And actually, remember, the order doesn't matter, because if it turns out negative, you're going to square it and the negative will disappear anyway. All right, so now we're going to do the simplification process. So 5 minus 3 is 2. When I take 2 and square it, I get 4. 3 minus 6 is negative 3. When I square it, I get positive 9. So our distance is the square root of 4 plus 9, which is 13. Sorry about that. I didn't realize I was off the screen there. All right, so that's the distance formula. And the answer is the square root of 13. And if you needed that to be a decimal, the square root of 13, let's check it so I can be precise, is 3.6. So this is approximately 3.6 units. All right, let's do that again, but now this one is going to be a little more complicated because we don't have anything to look at for our graph. All right, so this is what I mean. We have a line N. Okay, there was the bell. I have a line N, and it's right here on the graph. Sorry, let me move it down so you can see it. And I'm going to find the distance between this line and point R, which is really far away. Point R is at 2010 up here somewhere. So what I want you to be able to do is to find the distance without being able to graph that point. I don't want you to be able to just graph it. I want you to use the two equations and system of equations. So let me go through that process with you. First of all, we need to write the equation of line N. As you can see, its y-intercept is 0, and the slope from here to here is down 1 and over 2, so it's negative 1/2. So the equation of this line is negative y equals negative 1/2 x plus 0, but you don't write the 0. Okay, now we need a line that's going to be perpendicular to that. So we need the perpendicular slope. So we want the opposite reciprocal. So if I flip 1/2 over, I get 2, and the opposite of negative is positive. So the new slope we're going to use is 2. So now I need the perpendicular line that I'm calling Q, and so I'm going to use point slope. I'm going to take y minus 10. That's the y of the point that we're creating the perpendicular line from. We're going to put in our perpendicular slope 2, and then x minus 20. All right, so let's simplify this and get y alone. We're going to distribute the 2, and then we're going to add 10. I'm going to move over here so I have room. And so that's going to give me 2x minus 30. All right, so now I have my two lines. This is the thing that's different from example 1. I have line N and I have line Q. And so I need to find where they intersect. Somewhere on this line N they intersect. So to find that, I've got to use substitution, which would be a way of solving a system of equations. So what I'm going to do is I'm going to say negative 1/2 x. I'm going to replace y with negative 1/2 x because y is negative 1/2 x. And so this equals 2x minus 30. So there's our equation. When we solve this, we'll know what x is. So first I'm going to multiply everything by 2 so I don't have any fractions to worry about. That's going to give me negative x, 4x minus 60. And then I'm going to get x on one side by subtracting 4x from this side and subtracting 4x from this side. That will give me negative 5x. And that leaves me with negative 60. So the last thing we have to do is divide both sides by negative 5. When I do that, I get x equals 12. So I know what the intersection point's x coordinate is, but I still need y. So I'm going to take this 12, I'm going to plug it back into either of these equations. Well, this is an easy one. So I'm going to go y equals negative 1/2 x, but instead of x, I'm going to put in 12. So negative 1/2 times 12 means that the y coordinate is at negative 6. So therefore, the intersection point is 12, 6. So this point is on line N, and we want this point and our 2010, we want the distance between these two. So we now have to use our distance formula. We're going to use the distance between 2010, which is where we started with R, and the intersection point that we found at 12, oops, I forgot my negative, 12, negative 6. So we'll plug this into our distance formula. We're going to subtract our x's, 20 minus 12, and square it. We're going to subtract our y's, 10 minus negative 6, and square it. So 20 minus 12 is 8. when I square 8, that's going to give me 64. 10 minus negative, I would change that to 10 plus 6. 10 plus 6 is 16. And if you square 16, you get 256. All right, so now I can add these two numbers together to get 320. And then if you put that in your calculator, that means that the distance is approximately 17.9 units. And that's how you find the distance between 2 points or between the point and a line. If you have any questions, please let me know.